Hello students, in our previous class we learned about remainder theorem. That means how we can find the remainder when a polynomial is divided by another lower degree polynomial. Okay, in this class we will learn about factor theorem. Okay, so before learning factor theorem we have to learn what do you mean by factor. Factor means when a number is divided by another number, then if the remainder becomes 0, then we can say the first number is the factor of the second number. Like when 5 divides 40, then we have 0 as the remainder. So we can say 5 is the factor of 40. Similarly, when 13 divides 91, then we have 0 as the remainder, so we can say 13 is the factor of 91. Okay, so when a number divides another number, when a number is divided by another number and the remainder becomes 0, then we can say that the first number is the factor of the second number. Okay, example 5 divided by 40 will give 5 8s are 40. So remainder becomes 0. Implies that 5 is the factor of 40. Example 2. When we divide x cube minus x square minus 2x plus 2 by x minus 1, then let us study what the remainder comes. To get x cube, we have to multiply x by x square. So in the quotient there will be x square. X square into x will give x cube. X square into 1 will give x square into minus 1 will give minus x square. After subtracting, we have minus x cube plus x square. Then we can cancel this x cube and x square, and our rest of the term becomes minus 2x plus 2. Now to get minus 2x, we have to multiply this x by minus 2. X into minus 2 will give minus 2x. So at the quotient there will be minus 2. Minus 2x plus 2. After subtracting, we have plus 2x minus 2. Cancelling this, we have 0 as the remainder. So these imply, or so we can say that x minus 1 is a factor of x cube minus x square minus 2x plus 2. Okay. These are the preliminary things which help us to understand what do you mean by factor. Okay. So these are two cases. Now we will study what the factors theorem states. That means the statement of factor theorem. Let us study what factor theorem states. Let p of x be a polynomial of degree 1 or more, and a be any real number such that p of a equals to 0. Then we can then let p of x be a polynomial of degree 1 or more and a be any real number such that p of a equals to 0. Then x minus a will be a factor of the polynomial p of x. So this is the first part of the statement of factor theorem. This first part states that if p of x be a polynomial of degree 1 or more and a be any real number such that p of a equals to 0, then we can say x minus a will be the factor of this polynomial p of x. Okay. So there is the second part. Second part means the converse part of the statement. Conversely, if x minus a be a factor of the polynomial p of x, then p of a equals to 0. Okay, so this is the converse part of this factor theorem. This converse part of the factor theorem states that if x minus a be a factor of this polynomial p of x, then p of a must be equals to 0. Okay, now we will study how we can prove this factor theorem. So when we want to prove factor theorem, then we have to prove its both first part and the converse part simultaneously. Okay. proof. First of all, let P of x be a polynomial of degree 1 or more, and A be any real number such that P of A equals to 0. Okay, so here first we consider P of x be a polynomial of degree 1 or more, and for for any real number A, or we can say for a particular real number A, P of A is 0. Okay, so for this first part we consider this thing. So we have to prove that x minus A will be a factor of the polynomial P of x. Okay. Again, or now, by following remainder theorem, when the polynomial P of x will be divided by x minus A, then the remainder equals to P of A. Okay. So now if we follow remainder theorem, then when P of x will be divided by x minus A, then the remainder will be P of A. So if we apply division algorithm, then P of x is equals to Q of x into x minus A plus P of A, where Q of x quotient, Q of x represents quotient, that is a polynomial with degree less than P of x. Okay, and P of A is the remainder. Now I will also mention what the division algorithm states. Dividend since dividend is equals to quotient into divisor plus remainder. Okay, this is the division algorithm, that is dividend equals to quotient into divisor plus remainder. So by following this division algorithm, we have P of x is equals to Q of x into x minus a plus P of a, where Q of x is the quotient and P of a is the remainder. And we have always we have to mention this Qx as a polynomial whose degree must be lesser than the polynomial P of x. Okay. This imply P of x is equals to Q of x into x minus a plus 0, since from given we have P of a equals to 0. So these imply x minus a is a factor of the polynomial P of x. Okay, so this is the first part. First part states that when a polynomial P of x whose degree is 1 or more is divided by another polynomial x minus a for any real number a, then if P of a equals to 0, then x minus a will be the factor of this polynomial P of x. Okay, now we will study about the converse part of this theorem. For the converse part, we have x minus a be the factor of the polynomial P of x. We have to prove P of a equals to 0. Okay, so for this converse part, we have x minus a be the factor of the polynomial P of x, and we have to prove P of a equals to 0. Since x minus a is a factor of the polynomial P of x, therefore P of x is equals to quotient qx into x minus a imply remainder equals to 0, because already we know when a polynomial becomes the factor of the other polynomial, then for the case of division remainder becomes 0. So by following this theme, where since x minus a is a factor of this polynomial p of x, so we can say, we can write or represent p of x as q of x into x minus a, and this will imply remainder equals to 0. Okay. Again, by following remainder theorem, when p of x is divided by x minus a, then the remainder equals to p of a. So, by these two relations, so by 1 and 2, we can say p of a equals to 0, which proves the converse part of the factor theorem. Okay. So, by this way we can prove factor theorem. That means its two part, the first part and the second part, or you can say converse part. Okay. Now we will study how we can prove the problem number 2 by following this factor theorem. That means if we want to prove without this long division x minus a is a factor of this polynomial x cube minus x square minus 2x plus 2, then how we can proceed. Check whether x minus a be the factor of x cube minus x square minus 2x plus 2 or not. Check whether x minus b be the factor of x cube minus x square minus 2x plus 2 or not. Okay. So to check this, we have to we have to find the remainder. That means when this polynomial will be divided by x minus 1, then what will be the remainder? If the remainder becomes 0, then we can say x minus 1 is the factor of this polynomial x cube minus x square minus 2x plus 2. Okay. So let p of x equals to x cube minus x square minus 2x plus 2. When p of x is divided by x minus 1, then the remainder is equals to P of 1, since when we compare x minus 1 with x minus a, then we have a equals to 1. That is why when we divide p of x by x minus 1, the remainder is equals to p of 1 by following remainder theorem. By following remainder theorem, RT. RT is the shortest representation of remainder theorem. Okay, RT represents remainder theorem. So the remainder is P of 1. P of 1 means 1 cube minus 1 square minus 2 into 1 plus 2. This will give 1 minus 1 minus 2 plus 2. This will give 0. So this imply x minus 1 is the factor of the polynomial p of x by factor theorem. Okay. So by this way we can check x minus 1 is a factor of this polynomial p of polynomial x cube minus x square minus 2x plus 2. Okay. Now we will check some special form of the factor. Sometimes there will be not the exact form of the factor like x minus a. So in those cases, how we can find a? So uh, uh, these procedures of finding a will help us to calculate easily the value of a. If x plus p is a factor of the polynomial p of x, then p of minus p equals to 0. Then p of minus p equals to 0. Since x plus p is equals to x minus of minus p when compared with x minus a, we have a equals to minus p. Okay. Number 2, if cx plus d is a factor of the polynomial p of x, then p of minus d by c equals to 0. Since cx plus d is equals to, taking out c as the common factor, we have c into x plus d by c. And x plus d by c, that is x minus of minus d by c x minus of minus d by c when compared with x minus a, we have a equals to minus d by c. Okay, so in part 3, if x minus k is a factor no, when if x minus bk is a factor of the polynomial p of x, then p of bk equals to 0. Since x minus bk when compared with x minus a, then a is equals to bk. So these are the three general cases uh, which are not in the direct form of x minus a. Okay, so in those cases, how we can find a? It is clear for you. Now we will take an example. Prove that 3x plus 1 is a factor of 3x cube plus x square minus 3x minus 1. So here solution. Here 3x plus 1 is not in the direct form of x minus a. So first of all we have to find a. By following this case 2, we can find a. So to find a, we have to express this as, first of all we have to take 3 as the common factor. After taking 3 as the common factor, we have 3 into x plus 1 by 3. Then we can write this x plus 1 by 3 as x minus of minus 1 by 3. So these imply now comparing with x, now comparing x plus 1 by 3 with 1 by 3 with x minus a, we have a equals to minus 1 by 3. Okay. So, to prove 3x plus 1 be a factor of 3x cube plus x square minus 3x minus 1, first of all, we have to let p of x equals to 3x cube plus x square minus 3x minus 1. Okay. And then p of minus 1 by 3, p of a, that is equals to p of minus 3 minus 1 by 3 equals to 0. Okay. So for this problem, first of all, we have to calculate a. So here we have a equals to minus 1 by 3. Then to prove 3x plus 1 be a factor of this polynomial, first of all, there is no mention for this polynomial. That is why we have to let this polynomial as p of x. And then if we prove p of a or p of minus 3 equals to 0, then we can say a 3x plus 1 is a factor of this polynomial p of x. Okay. By following factor theorem. Therefore, p of minus 1 by 3 is equals to 3 into minus 1 by 3 whole cube plus minus 1 by 3 whole square minus 3 into minus 1 by 3 minus 1. 3 into minus 1 by 27 plus 1 by 9. 3 cancelled out. This becomes plus 1. This is minus 1. 3 9s are 27. So this will give minus 1 by 9 plus 1 by 9. We can cancel this plus 1 minus 1, and after cancelling this minus 1 by 9 plus 1 by 9 we have 0. So this imply 3x plus 1 is a factor of the polynomial p of x by factor theorem. Okay. In our next class, we will study some applications of remainder theorem as well as factor theorem. Then how we can factorize cubic or biquadratic expressions properly with the help of factor theorem. Okay.